All right, your practice sheet for Friday's quiz. Now, even if you don't like these methods, I do want you to be familiar with them. So, yeah, you're going to have to do the box method, vertical multiplication, all that good stuff. So, using the box method, find the product. And, I've seen some kids switch over to the box method. It just makes sense to them. Let's see, I'll just let this be x and -2 and top be 2x plus 4. It doesn't really matter which one you put where. It really doesn't. So x times 2x is going to be a 2x squared. X times 4 is 4x. -2 times 2x is minus 4x. It's good for kids who just need some sort of organizational strategy. -2 times 4 is -8. And then we're going to combine like terms. So there is a 2x squared. All right. Oddly enough, these worked their way out, didn't they? We have a positive 4x and a negative 4x, and that makes no x, so we're not going to write that down. And then we have minus 8. There you go. 2x squared minus 8. All right, using the vertical multiplication algorithm, find the product of 2x minus 3 and x plus 5. Usually you put the bigger one up top. Usually. You don't have to. Just works out. And we're going to multiply. We're going to go old school. So maybe you forgot how old school works, like 63 times 16. 6 times 3 is 18. Here we carry the 1. 6 times 6 is 36. Add 1, 37. And then we put a 0. 1 times 3 is 3. 1 times 6 is 6. And then we add down. 8, 11. Oh, sorry, that's 10, isn't it? That's 7. 10, carry the 1. And 4 and 6 makes 10. 1008. Now, with polynomials, you don't have to worry about the carrying aspect of things. Let's see, 5 times -3 is a -15. 5 times 2x is 10x. And there is a 0 here. It's there because we need to shift left. X times -3 is -3x. X times 2x is 2x squared. And we still add down. So -15 plus 0 is -15. 10x minus 3x is positive 7x. And then you have your 2x squared. So 2x squared plus 7x minus 15. Using the double distributive property, aka the FOIL method, do 3x plus 4 times x minus 5. I'm missing a parentheses there, aren't I? If I can get a kid to draw arrows, they get these things. 3x times x is 3x squared. 3x times -5 is minus 15x. And that's the hard part, is getting a kid to just draw arrows. 4 times x plus 4x. 4 times a -5 minus 20. These two pieces can be put together. -15 plus 4 is -11. Ta-da! All right, moving forward. We write in standard form if needed, then factor in the zero product property to solve for x. Now, standard form is your ax squared plus bx plus c. This one's already in standard form, but if you need to know that there's a 0 there, like if it helps you and makes you feel good about yourself, you put a 0x there. Now, I am seeking factors of -16 that add to nothing. Okay, I seek factors of -16 that add to 0. That's probably worth typing out for you because I know not everybody can factor. I can think of 5 kids off the top of my head right now. But we seek factors of -16 that add to 0. Now, something else I know, this is going to have a double set of parentheses. To make the x squared, we have to lead with an x in both of them. And you talk about factors of -16, you're talking about a positive 4 and a -4. Ta-da! Now, number 5 is not in standard form. Some kids just like to factor without doing the first step. And the first step is to put it in standard form. You're going to shift your 81x over, make it look like this. Now, I have what's called a binomial. I have 2 terms. I only need a single set of parentheses. I need to think about what each of these 2 pieces have in common. I know that they both are divisible by 9, and they both contain at least 1x. So I can pull a 9x from both of them. If I pull a 9x from 9x squared, I'm thinking about division. 9's cancel. X squared over x is just x. That leaves me with an x. If I pull a 9x from a -81x, the x's cancel, and -81 over 9 is -9. And that's how she factors. 9x times x minus 9. All right, moving forward. Number 6. To make a 3x squared, and this is guess and check and all that good stuff, it takes a 3x and an x.
This is a public radio. I can't say what I want to say.
Factors of 20 are 4 and 5. All right, so factors of 20 could be 4 and 5, or maybe 2 and 10, or maybe 1 and 20. Let's play with 4 and 5, and let's think about where we place them. A lot of kids, they just guess, but they don't check. And it's called guess and then check. 5 times 3 is 15x. 4 times 4 is 4x. And think about your goal here is negative 11. I need the 15 to be negative because negative 15 plus 4 is negative 11. You know, guess at it, check it. If it doesn't work, switch things around. All right, number 7, not in standard form. It has to be in standard form first. First thing we're going to do is we're going to move that 10 over. I'll probably show you 2 different ways of doing 7. Oh, me being a dummy, I've got to go back and do all these over. It says use the zero product property to solve for x. So after I finish 7, I'll go back through and we'll use the zero product property. All right, so let's just start off this one the way she is. I'm going to go with a 4x and a 3x, create 12x squared. I could have made my work a little easier on this one. Factors of 10 are going to be 2 and 5. And I know this works. The outside makes 20x, the inside makes 6x, and negative 20 plus 6 is negative 14. Now, and if you catch on to this, little things like this can work. Every single number is divisible by 2. I can pull that 2 from the get-go, and I can make the factoring process just a little bit easier. And I say it's just a little bit easier because I have fewer choices. To make a 6, I can be a 2x or a 3x. To make a 5, I can be a 1 or a 5, or it could be a 1 and a 6, but let's try 2x and 3x. See over here on 12, I could have been 1 and 12, 3 and 4, 2 and 6. I had 3 choices. With a 6x squared, I only have 2 choices of factors. To make a 5, I got to be a 1 and a 5. Now this time I want to add to negative 7. Now the outside's going to make 10x and the inside's going to make 3x. I need the 10 to be negative. And that's how it factors. Now, I forgot to solve. I was so caught up on factoring that I forgot to solve. So let me go back up to 4. It says use zero product property. So x plus 4 is equal to 0, or x minus 4 is equal to 0. If x plus 4 is 0, x is negative 4. And if x minus 4 is 0, x is 4. Really simple. This guy, 9x equals 0, or, and hear me out, x minus 9 is 0. So 9x equals 0, or x minus 9 equals 0. Now, if 9x is equal to 0, I would just divide by 9. 0 divided by anything other than 0 is 0. So x is 0 as a solution. Here is a simple shift right, x is 9. All right, what am I looking at now? I'm looking at 3x plus 4 times x minus 5. Just use your zero product property. 3x plus 4 is a 0, or x minus 5 is a 0. We're going to subtract 4 from both sides. 3x is negative 4. Divide by 3. X is negative 4/3. We're just going to add 5 to both sides. X is 5. And it didn't matter down here which one of the ones you did. They both would yield the same result. I'm just going to use the original. 4x plus 2 is a 0, or 3x minus 5 is a 0. We're going to take away 2 from both sides. 4x is a negative 2. We're going to divide by 4, and obviously we're going to reduce the fraction. Negative 2 over 4 reduces to negative 1/2. We're going to add 5 to both sides. 3x is 5. We're going to divide out that 3, and x is 5/3. Easy peasy, lemon squeezy. I'm going to pause and take a break for just a second. My brain is tired. BRB. All right, number 8, graph f of x equals negative 2 times x minus 3, quantity squared, plus 4. State the domain range, the minimum or the maximum, and the axis of symmetry. So remember, this is about a lineup process. A is -2. Now we're graphing, okay? So this means the initial slope is to fall 2 and run 1. Instead of opening up, this thing opens down. H is not -3, it's just 3 because the form is minus. This means shift right 3, and K is 4. This is up 4. So what these last two things are telling me is they're telling me that the vertex is at 3, 4. That's where the vertex is. And that's where you start. We go right 3 and we rise 4, just like the shifts were saying I would do. And now we kick in this initial slope, and the initial slope was to fall 2 and run 1. Now, you are supposed to know that the mom function here is x squared, and she's a parabola. So you can't just plot one point and be done. You fall 2 and run 1 both ways, and we've had that discussion. It is not asking for x-intercepts. We're not going to worry about them. If it asked for it, we'd take the time to do it, but it's not asking for it, so we're just going to do that. Be done with it. All right, now, the axis of symmetry will actually be the first thing I do because I like it. Most kids don't want to draw it in. That is literally at x equals 3. So the axis of symmetry, that is a vertical line at x equals 3. What else do we need? We need the domain. Now, every parabola we've ever graphed in here has run left forever and run right forever. It's always been negative infinity to infinity. Or if you like set builder, all values of x such that x is an element of the real. Your range, the low y value is down here at negative infinity, and on either side of the parabola, it rises to a high y value of 4. With a bracket, because that's a solid dot. Now, min or max, that's the question. Is this a min or a max? It's a max. The maximum y value is simply y equals 4. It's a really easy problem. Will a lot of kids miss it? Yes. Yes, they will. And that's on you, not me. All right, number 9, graph this one, which is in standard form by finding the vertex, the y-intercept, the line of symmetry, and one other point using the line of symmetry. So let's go through here. The vertex H, or x subscript v, whatever you like to think of, is found as opposite b over 2a. And let's go through our labeling here. A is 3, b is -6, and c, even though we don't need it, is -5. So the vertex would be at -6 divided by twice a 3. Now, I want to show something here because some of you, bless you, you will go to a calculator and you'll type this. Shame on you for doing that, but the calculator is wrong because of the way you typed it. If you're going to be using a TI-84 to think for you, do this. Go to Math, Num, N over D. Do that first, -6, and then over 2 times 3. Or learn how to wrap things in parentheses. Notice how I wrote it out on a piece of paper? Parentheses, twice a 3. You should be getting -1. Now that's how you get H. K is a Y value. So to find K, plug H back in. So K is going to be the result of plugging in that -1. And if you don't want to do that in your head, you don't have to. It ain't going to kill you. That's going to be a -1 squared is 1 times 3 is 3. A negative times a negative is positive, so +6 and then -5. And that's going to be 4. And I know for some of y'all that seems like some sort of magic I just did. But let's just use the storage feature. Take a -1, store it to x. Type in the original equation, which was 3x to the second. And then it was -6x. And then I think it was -5. Ta-da! All right, to find a y-intercept, we simply let x be 0. So 3 times a 0 squared, -6 times a 0, and then -5. Don't be surprised that you get -5 back. I've talked about this. That's always the y-intercept if you're in standard form, and you get -5 back. So let's see here. We have a vertex is at negative 1, 4. So back one, rise 4. We have a y-intercept at negative 5. And here's where the line of symmetry comes into play. The line of symmetry is at x equals negative 1. It always passes through the vertex. And if I have a point 1 unit to the right of the line of symmetry, I have another point that is 1 unit to the left of the line of symmetry. And there is my parabola. And again, it's not a hard question, but will a lot of children miss it? Yes, they will. That's a given. It's math. It's on them. Truth is, they just don't want to learn it. That's the reality of it. All right, the graph of fx is shown. Determine which intervals is positive, determine which intervals is negative. This ought to be fairly simple. Positive means above x-axis, and negative means below x-axis. So I'm positive on these intervals here and here. Of course, now interpreting this is a little bit harder to do. If we like inequalities, we would say this happens when x is less than negative 2, and this happens when x is greater than 2. So that's one way of answering for positive. I could do all values of x such that x is less than negative 2, comma, x is greater than 2. Or if I like interval notation, being less than negative 2 means negative infinity to negative 2. And notice I use parentheses because I did not have equality anywhere in the question. Union with the other side, which is 2 to infinity. Now let's do negative. The negative space is below the x-axis, which is all this stuff right here. And it happens when x is literally stuck between Milbrath, bad Milbrath. Bad Milbrath. Well, I'm going to erase a lot more than I want to here. I just caught something. That was negative 1, wasn't it? There we go. Sorry about that. This happens right here when x is negative 1 and between x being 2. So we're negative as long as x is literally stuck between negative 1 and 2. So if I like my set builder notation for all values of x such that x lies between negative 1 and 2, or, and most of you will probably use interval notation because it's just parentheses negative 1 comma 2 close parentheses. Interval notation is easier, but it doesn't specify what variable you're talking about. That's the only glitch, I guess you'd say, that interval notation has. It's somewhat vague. All right, I'm going to pause a second. I'll be back in just a minute. All right, you wish to create a dog run in your backyard. You have 400 foot of fencing material at your disposal if you wish to use the house as the fourth side of a rectangle. So let's talk about what we have here. Going to make something simple, a rectangular backyard. And this is the fourth side. It's not really there because it's the house, right? Now, this particular rectangle has a width and a length. It doesn't have all three sides. So if I talk about the perimeter of this rectangle in regards to the material I have, its perimeter is a single length plus 2 widths. So this is part 1. Now, the perimeter is 400 foot, so it's 400 equals a single length plus 2 widths. Now, the area of any rectangle is length times width. So there's my other equation. Now, part 2 says solve your perimeter equation for either the length or the width and substitute that into your area equation. Write your area equation in standard form. So it's really simple to solve this one for length. The length is simply 400 minus 2 widths. Now, what can I do with that? I can take that and I can plug it right in. Now what I have is I have area as a function of W because the only variable in here is going to be W. So area as a function of the width is 400 minus twice the width times this width right there. And we'll clean that up using the distributive property. That'd be 400W minus 2W squared, which in standard form is negative 2W squared plus 400Ws. So there is your equation. Find the dimensions that maximize the enclosed area. This always happens at, in this case, W, because it's width, opposite B over 2A. It's about width this time, not X, width. So anyways, looking at this equation, I thought, my tongue got tied. A is negative 2, and B is 400. So the width that maximizes area is going to be a negative 400 over twice a negative 2. Now that's going to be negative 400 over negative 4. A negative over negative is positive. 400 over 4 is 100. I feel that every junior should be able to figure that out. So the width is 100 foot. Now, if the width is 100 foot, and remember, I had 400 feet at my disposal, right? Then the length has to be 200. Because 400 minus 100 minus 100 is 200. So the width ended up being 100, and the length ended up being 200. All right, part 4, find the area of the enclosed area. Find the area of the enclosed area. Just go back up to this guy. The area would be 100 times 200. Now 1 times 2 is 2, and there are 1, 2, 3, 4. 1, 2, 3, 4. 20,000 square foot. Now, if you want to know what is this in acres, because I think people have a good idea of what an acre of ground looks like. It's not that big. We take our 20,000 square feet and we divide it by 43560. I'm just going to grab my calculator and push some buttons. Yeah, it's a little under half an acre. I got 0.46 acres. Of course, now if you're a city person, you have no idea what an acre of ground looks like, but it's not that much. It's really not that much. All right, there's 11. 2 more to go. You have decided to roll a small tree in Coach K's yards. The tree stands 20 foot tall, throwing from a height of 6 feet and 14 foot from the center of the tree. You will clear the tree by 11 foot. Now, I've got a grid here, but it's not going to do any good. We're just going to have to kind of arbitrarily come up with the numbers. There's a tree, and here's my tree. Nothing special. You are standing 14 feet from the center. So this would be 14, 0. And you're here, okay? This is where you are. You are throwing the roll of toilet paper from a height of 6 feet. So here's your roll of toilet paper. It starts its path at 0, 6. It's going to go up and over the tree and then come back down. Now, you're going to clear the tree by 1 foot. Remember, the tree is 20 foot tall. You're going to clear it by 1 foot. So at the center of the tree, your ordered pair is going to be 14, 21. Because it was 20 foot tall, you cleared it by a foot. And there you go. That's what you have to have. Write an equation modeling your act of vandalism in both vertex form and standard form. So let's do part 1, which is vertex, which is y equals a times x minus h, quantity squared plus k. And h and k are kind of given to you now that you've done a diagram. H is 14, k is 21, so y equals a times x minus 14, quantity squared plus 21. Now, how do I figure out a? Well, we've done this in here. Every ordered pair in existence gives you an x and a y, and you can plug them in. So y is 6 when x is 0. Now, of course, you know, if you don't know what 0 minus 14 is and then squared, I guess you can push buttons. Should be 196, but what do I know? I am pretty tired today. There's 0 minus 14. But that's square key, 196. So 6 equals 196a, and then plus the 21. And now we're going to do some two-step algebra. We're going to subtract the 21. 6 minus 21 is negative 15. And then we're going to divide out the 196. Nobody said this was going to be pretty. It's trying to model the real world. And in the real world, the numbers are hideous. I don't believe that fraction simplifies. I don't want the decimal. And it didn't. So A is negative 15 over 196. So here's my final equation. This is the answer, by the way. You got to put that right there where it belongs. Y equals negative 15, 196 times x minus 14 quantity squared plus 21. That's part one. Part two is vertex, sorry. Part two is standard form. I hate it for you kids that just kind of fast forward and don't copy stuff down until you see an answer. I just erased a lot of work. Anyways, part two is standard form, which is ax squared plus bx plus c. So we're going to take our funky equation. We're going to write this piece twice because it's squared. And it's going to be kind of ugly. But now we're going to figure out what x minus 14 times x minus 14 is. So we're going to have to do a little foiling. X times x is x squared. The inside is going to make negative 14x, as is the outside. And if we add those, it's minus 28x. And then negative times negative is a positive, and 14 times 14 is 196. We've already been through that. And then plus 21. Now, do not be the kid that adds 21 and 196 yet. First thing you have to do is you have to distribute this negative 196 in. So sadly, there's a little more work here. And it's going to be ugly. But anyways, we're going to use the distributive property. Negative 15 196th x squared. Let's see what this one's going to be. Let's see if that cleans up any. And I'm too tired to do this in my head. Yeah, let's just pretend you weren't playing along. So I'm going to take that negative 15 over 196. I'm a little old school, so notice I'm just using parentheses. And I'm going to multiply it by the negative 28. Math, enter, enter. 15 sevenths. So plus 15 sevenths of x. And this time I'm going to be multiplying by 196. Oh, it was negative 15. And then finally, don't forget about this guy, plus 21. Negative 15 196th x squareds plus 15 sevenths of x. And then negative 15 and 21 adds to what, 6? Which makes sense because that was the y-intercept. So I'm not surprised there. And I think there's one more. Johnny was there to jump off a cliff into the water below. Some of you guys have probably done this. He climbs up a 128-foot cliff, maybe not that tall, places himself on the edge and jumps as hard as he can. Now, you should not do this. You should not do this because there might be rocks under the water, right? Propelling himself upwards at 32 feet per second, an equation relating height and the time of his jump is given as height as a function of time is negative 16t squared plus 32t plus 128. Part one is determine Johnny's maximum height above the water. Again, this happens here where the time would be opposite b over 2a. So the time that it happens is going to be a negative 32. And by the way, I keep forgetting y'all don't know things. A is negative 16, B is 32. So it's going to be opposite of a positive 32, which is negative 32, over twice a negative 16. You know, that ends up being negative 32 over negative 32, which is -1. Interesting. +1. So that's 1 second. Now, that's not what the question asked. The question didn't ask at what time does he reach his maximum height. It says determine it. So what we're going to do is we're going to plug in the 1 second. The height in 1 second is -16 times a 1 squared plus 32 times a 1 plus 128. If doing this is beyond you, push buttons. But this is going to create a -16. -16 plus 32 is 16. 16 plus 128 is 144. And that would be in feet, because this is America. We use feet. All right, determine when Johnny hits the water. So, the idea here is that Johnny has climbed up on a cliff. And I used to say there might be rocks or something in there and you decide what happens to his fate. But this year I got to be a little more polite. But he jumps up and then he comes down. And he's going to dive into the water safely and live happily ever after, right? Something like that. Probably not. He takes a lot of risks in life. But anywho, I want to know where the x-intercepts are. That's what that is. That is an x-intercept. So what I'm going to do is I'm going to factor. I'm going to use zero product property. So we're going to take our equation. We're going to replace the height with 0 because that's where the water would be, 0 feet. And I'm going to factor it. Now, one of the things I'm going to do is I'm going to pull this -16 from everything. If I divide 32 by a -16, I get a -2. If I divide 128 by -16, I get a -8. And now I'm going to factor some more. Hopefully you're good at factoring by now. It takes a t and a t to create a t squared. Factors of 8 are 4 and 2. Remember, you need to add the -2. So -4 plus 2. Now we're going to use the zero product property. T minus 4 is a 0 or an x-intercept, or t plus 2 is a 0. Now this one says the time is 4 seconds. This one says the time is -2 seconds. We call this extraneous. I don't know if I've talked about that with y'all or not this year, but that is extraneous. It's a nonsense solution. That's saying that he hit the water 2 seconds before he jumped. He did not. That represents this case over here, which on a graph is there, but in the real world it's not. 4 seconds till he hits the water. And I believe that's the last one. Thank the Lord it is, because I'm wore out. So anyways, that's going to be Friday. Hope you enjoyed the video.